Good morning, my dear students. Now in yesterday video clips, that is what is the meaning of the charge, what is the meaning of electrification, what is the meaning of electrified or said to be charged, and what are the methods are used to charging the body, all these things in the video clips, previous video clips. Now today the very important point, that is Coulomb's law. Now what is the electrostatic force? That is important. Now the force exists between the two electric charges apart at a small distance, that is called electrostatic force. The force exists between two point charges are placed apart at a distance. This is called electrostatic force. It is Coulomb's law. Coulomb's law, it gives the relation, it measures the force. It measures the force. It gives the relation between force, charge and the distance. The Coulomb's law states that the electrostatic force between the 2 point charges separated by certain distance is directly proportional to product of the magnitudes of the two charges and is inversely proportional to square of the distance between them. Here F is Q1 and Q2 are the 2 point charges, F is the electrostatic force and R is the distance between the 2 point charges. Now this is proportional to Q1 into Q2, product of the magnitude of the two charges, and is inversely proportional to square of the distance between them. Therefore, by Coulomb's law, F proportional to Q1 into Q2 upon R square, F is equal to K, Q1 into Q2 upon R square. Now K is the proportionality constant. That constant, proportionality constant, depends on the medium in which the charges are placed. And SI system, that is a system of unit use. Suppose you use the SI system, at that time K is 4 pi epsilon naught. K value is 1 upon 4 pi epsilon. What is epsilon naught? Epsilon naught is permittivity. You said to be permittivity of the free space. Permittivity. What is permittivity? Permittivity is the property of the medium which gives the response to the electric field lines. That is called permittivity. The permittivity unit is 8.854 into 10 to the power of minus 12 Coulomb square per Newton meter square. What is Coulomb? Coulomb is the SI unit of the charge. Coulomb is SI unit of the charge. It is represented by capital letter C symbol. Okay. It is the permittivity of the free space. Its value is 8.854 into 10 to the power of minus 12 Coulomb square per Newton meter square. Now, 1 upon 4 pi epsilon naught, 1 upon 4 into 3.14 to 8.85, 4 into 10 to the power of minus 12, you got the value 9 into 10 to the power of 9 Newton meter square per Coulomb square. When the charges are placed in air medium or a free space, at that time force becomes Fk is equal to 1 upon 4 pi epsilon naught Q1 into Q2 upon R square. Instead of K, I have to write 1 by 4 pi epsilon naught. Is the expression of the electrostatic force between the 2 point charges when the two charges are placed in a air medium or free space. If the medium is other than air ಹೊರತುಪಡಿಸಿ ಬೇರೆ ಯಾವುದೋ medium ಇದ್ರೆ, now K is 1 upon 4 pi epsilon naught into epsilon r or 1 upon 4 pi epsilon. Here epsilon is epsilon naught into epsilon r. Now what is epsilon naught? Permittivity of the free space. What is epsilon r? It is relative permittivity. Epsilon r is relative permittivity. Now epsilon permittivity of the free space. Permittivity of the medium. Epsilon naught permittivity of the free space. Epsilon or relative permittivity. Relative permittivity, one more point, one more name is for relative permittivity is dielectric constant. Yes, now at that time force becomes Fm is equal to 1 upon 4 pi epsilon naught into epsilon r q1 into q2 upon r square, or Fm is equal to 1 upon 4 pi epsilon q1 into q2 upon r square. Either epsilon naught into epsilon r you have to write, or you write simply epsilon, because epsilon is epsilon naught into epsilon r. Now Coulomb's law in vector form you have to write. In the vector form you have to write here. Coulomb's law in vector form. It is very important. This is very important. Suppose ask in the examination, write the Coulomb force between the 2 point charges in the vector form. At that time you have to write the expression this one. Yes. Now in space 3 dimension you have to write here. But you use that is a 2 dimension plane only xy. Q1 is the charge, Q2 is the charge. Is placed at these 2 points. Suppose you say to be A, this is you say to be B. It is the origin. R1 is the position vector for Q1, R2 is the position vector for you say to be Q2. Distance between these two from this direction is R21. Suppose you take this direction, that is you say to be R12. Now, what is F12? The force act on Q1 by Q2 in this direction. What is F21? The force act on Q2 by Q1. When you take the force act on Q1 by Q2, F12, at that time you take the distance R12. When you take the force act on Q2 by Q1, at that time you take the distance R21. Now, F vector F12 is equal to 1 upon 4 pi epsilon naught Q1 into Q2 upon R12 square into R12 cap. It is a vector form. The force between the 2 charges in the vector form. That is Coulomb's law. Yes. This is F12, force act on Q1 by Q2. Force act on Q2 by Q1 at that time 1 upon 4 pi epsilon Q1 into Q2 upon R21 square 21 square is equal to into R21 cap. Here R12 is equal to minus R21. Suppose you take the magnitude R12 is equal to, that is you say to be R21. R12 magnitude is equal to R21, its magnitude. Now from this direction to this direction you measure 3 centimeter. From this direction to this direction is also 3 centimeter, like that. But vector R12 is equal to minus vector R21. Therefore vector F12 is equal to minus F21, or vector F21 is equal to minus F12. Now in the vector form also you have to write this expression, that is vector F is equal to 1 upon 4 pi epsilon naught Q1 into Q2 divided by R square into N cap. Few students you write like this, but according to NCERT syllabus, must and should you have to write the force between the 2 point charges in vector form. You write F12 or you say to be F21. Thank you. Yes, my dear friends. Now, by using that is the force equation, you define the SI unit of the charge. The SI unit of the charge is Coulomb. The SI unit of charge is, what do you say? Coulomb. Now, the force between the 2 point charges in the air medium 1 by 4 pi epsilon Q1 into Q2 upon R square. Now, you take the Q1 is equal to 1 Coulomb, Q2 equal to 1 Coulomb, R is equal to 1 meter. Then you substitute. Fa is equal to 1 upon 4 pi epsilon naught value is 9 into 10 to the power of 9. Then 1 into 1 divided by 1 square, it becomes 1. Then Fa is equal to 9 into 10 to the power of 9 Newton. Now define 1 Coulomb. The 1 Coulomb is that charge. The 1 Coulomb is defined as that charge, which is placed at a distance of 1 meter from the identical charge. From identical charge, it experiences the force of repulsion, distance is 1 meter in the free space, it experiences the force of repulsion 9 into 10 to the power of 9 Newton. Once again I repeat the definition. 1 Coulomb is defined as that charge which is placed at a distance of 1 meter from identical charge in air or free space, which experiences the electrostatic force of repulsion 9 into 10 to the power of 9 Newton. This is the definition of 1 Coulomb. ಅಂದ್ರೆ ಇದು 1 Coulomb ಅನ್ಬೇಕು ಅಂದ್ರ ಅಂತದೇ ಒಂದು ಚಾರ್ಜ್ ನಿಂದ 1 ಮೀಟರ್ನಲ್ಲಿ ದೂರದಲ್ಲಿ ಇಟ್ಟಾಗ ಇದರ ಮೇಲೆ ಆಕ್ಟ್ ಆಗತಕ್ಕಂಥ ರಿಪಲ್ಸಿವ್ ಫೋರ್ಸ್ 9 into 10 to the power of 9 ನ್ಯೂಟನ್ ಇರುತ್ತದೆ. ಆವಾಗ ಇದು 1 Coulomb ಅನಿಸಿಕೊಳ್ಳುತ್ತದೆ. This is the definition of 1 Coulomb. Now dielectric constant. When charges placed in air medium, the force between the two charges are 1 upon 4 pi epsilon naught Q1 into Q2 divided by R square. The same charges placed in other than air ಅಥವಾ medium in the medium of dielectric constant epsilon r, at that time the force equation Fm is equal to 1 upon 4 pi epsilon naught Q1 into Q2 divided by R square. Instead of epsilon naught you take the epsilon r here. Now divide these two, Fa upon Fm. What do you hear? Epsilon r is the dielectric constant, relative permittivity. Yes, that is 1 upon 4 pi epsilon naught Q1 into Q2 divided by R square divided by 1 upon 4 pi epsilon naught into epsilon r Q1 into Q2 divided by R square. This term is cancelled. This term is cancelled. Fa upon Fm is equal to 1 upon 1 by epsilon r. It becomes epsilon r. Epsilon r is equal to Fa upon Fm. It is a dielectric constant, or is said to be relative permittivity. The dielectric constant of the medium is defined as the ratio of the force between the 2 point charges when placed in a air medium apart at a distance to the force between the same 2 point charges apart at a same distance when placed in that given medium. This is the definition of dielectric constant. Here Fa is always greater than Fm. ಅಂದ್ರೆ ಫೋರ್ಸ್ ಬಿಟ್ವೀನ್ ದ 2 ಪಾಯಿಂಟ್ ಚಾರ್ಜಸ್ ಏರ್ ನೊಳಗೆ ಯಾವಾಗಲೂ ಹೆಚ್ಚಿರುತ್ತ, ಮೀಡಿಯಂ ನೊಳಗೆ ಕಡಿಮೆ ಇರುತ್ತೆ. ಹಾಗಾದ್ರೆ Fa upon Fm is greater than 1. Therefore epsilon r is always greater than 1. ಅಂದ್ರೆ ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಮೀಡಿಯಂ ಮತ್ತು ಯಾವಾಗಲೂ ಗ್ರೇಟರ್ ದೆನ್ 1 ಇರುತ್ತದೆ. ಯಾವಾಗಲೂ ಗ್ರೇಟರ್ ದೆನ್ ಅಂದ್ರೆ ಮೋರ್ ದೆನ್ 1, 1.2, 1.4, 2 point something, 200 something, 100 something, 140 something, like that. Different medium having different dielectric constant. Paper, water, so many dielectric ceramic, so many dielectric medium having the dielectric constant, they are always greater than 1. Okay, thank you. Then next video will force between the two multiple charges. Good morning, students. Now in this video clip I want to explain the force act on single charge by 2 or more charges. Now see here, Q1 is the charge, the force act on Q2 and Q3. It means for the multiple charge, force between the multiple charges. Now you have to take here for 3 charges, Q1, Q2, Q3. Q1 is the charge, Q2 is at a distance R12 vector R12, Q3 is at a distance vector R13. Now force act on Q1 by Q2 is vector F12. Then force act on Q1 by Q3 is vector F1 3. The force act on Q1 by Q2 is vector F1 2. Force act on Q1 by Q3 is vector F1 3. Now this F1 2 is in this direction, F1 3 is in this direction. What is the resultant force act on Q1 by Q2 and Q3? That is said to be vector F. Now force act on Q1 by Q2, vector F1 2 is equal to 1 upon 4 pi epsilon Q1 into Q2 by R12 whole square into R12 cap. The force act on Q1 by Q3, vector F13 is equal to 1 upon 4 pi epsilon naught Q1 into Q2 by R13 square into R13 cap. It is in this direction. According to the principle of superposition, the net force act on the Q1 is factor sum of these two superpositions according to superposition principle. That is 1 by 4 pi epsilon Q1 into Q2 by R12 square into R12 cap plus 1 by 4 pi epsilon Q1 into Q3 divided by R13 square into R13 cap. This is the net force. Sum of these two vectors, this one, but magnitudes are not equal. It is in the previous year, in previous first year in the vector. Suppose what you say, vector A plus vector B is equal to vector C, but modulus of the vector A, modulus of the vector B is not equal to vector C, modulus of the vector C. But how you got the resultant force? How you got the resultant magnitude of the resultant force? You got the magnitude of the resultant force according to there is a parallelogram law of forces you have to take under root of F12 square plus F13 square plus 2 F12 into F13 cos theta. Like that you have to use this formula, you have to calculate it, whatever it may be. This is about for the 3 charges. It means force act on single charge by 2 charges. For many charges, there is a group of more than 3 charges. The force act on single charge for many charges, Q2, Q3, Q4, Qn, Q and so on, like that. The net force F12 force act on Q1 by Q2, F13 force act on Q1 by Q3, F14 force act on Q1 by Q4 and so on. That is said to be F. Now vector F is equal to 1 by 4 pi epsilon Q1 into Q2 upon R12 square, the R12 cap plus 1 by 4 pi epsilon Q1 into Q3, R13 square into R13 cap plus so on 1 upon 4 pi epsilon Q1 into Qn divided by R1n square into R1n cap. Here 1 upon 4 pi epsilon Q1 is common here, Q2 upon R12 square, R12 cap plus Q3 upon R13 square, R13 cap plus Q1 divided by R1n square, R1n cap. Then finally, vector F is equal to Q1 divided by 4 pi epsilon summation over Qi divided by R1i to R1i cap. I is from 2 to n. I is equal to what to say 2, 3, 4, 5 and so on up to n. This is the force act on single charge by many charges, more than 2 charges. This is the force act on single charge by 2 charges. Thank you. Good morning, my students. Now, in electrostatics, I want to explain the new concept that is said to be electric field. Already you know that is the electric charge. That is the electric charge. And what is the electric force? Electrostatic force. Electrostatic force is measured by the Coulomb's law. What you say? That is Coulomb's law. With the help of Coulomb's law, how to measure the force? That F is equal to 1 upon 4 pi epsilon naught Q1 into Q2 divided by R square. And the 2 charges are placed in the air medium. Now, the important concept is said to be the electric field. What is the electric field? Now you take any charge here. Any charge. Now, there is a region or a space around the charge. There is an electric field. electric field ಇರ್ತಾರೆ. Now how you define? Another charge is placed here. Another charge Q is placed here. What happens? It experiences the electrostatic force of repulsion, or is said to be attraction. But here, this is the charge positive. This is also said to be charge positive. This is said to be test charge. What is test charge? Test charge is the very small charge which is placed in the electric field. It does not affect on the existing electric field. That is said to be test charge. Suppose you take the test charge Q. With the help of test charge, you have to confirm whether electric field is there or not. Once you place at the point in the electric at this point, now what happens? It experiences the electrostatic force. At that time you say there is an electric field. How you measure that electric field? What is the expression for the electric field? That is, the electric field is represented by, that is said to be E. Now charge is scalar. It is a scalar quantity. It is measured in Coulomb. Force, electric force, it is a vector quantity. It is a vector quantity. Therefore, you write the expression for the electric field, that is the electric force by Coulomb's law in a vector form. It is asked in the examination. Now come to the point of here. This is the charge Q is placed in the air medium. P is the point, Q is the test charge. Suppose you said to be unit positive charge is placed at this point. What happens? Electric force, that is the electric force act on this one. F is equal to 1 by 4 pi epsilon naught Q into Q divided by what you say R square. What you say? This is the R square. Now it is in the vector form. You have to write here vector F is equal to 1 by 4 pi epsilon naught, that is Q into Q divided by R square into R cap. You have to write this one. Then how you measure the electric force at this point P, that is the electric field at this point. Now that electric field at this point is measured by the ratio of the electrostatic force act on the charge to that charge which is placed at that point P. Now you measure like this. How you measure? It is measured by the ratio of electrostatic force act on the charge to the charge. Ratio of this gives the electric field. Now that is the electric field is equal to what you take the electrostatic force 1 by 4 pi epsilon naught Q into Q divided by what you say R square into what you say, that is R cap. Yes, divided by what you say Q. Q get cancels. What you got here, electric field is equal to 1 by 4 pi epsilon naught Q divided by R square. Instead of R square, you said to be R cap, you said to be unit vector N cap. Now this is the expression for the force. Instead of this one, you have to write vector E is equal to 1 upon 4 pi epsilon naught Q divided by what you say R square into N cap. N cap is the what is this is unit vector. Yes, this is the unit vector. It is the expression for the electric field at this point P. Is the vector. It is a vector quantity. It is represented by, that is the vector E. Now from this expression, now see here, this is the electric field expression. Now suppose the charge is charge is positive. What is the direction of the electric field? The direction of the electric field, it is along what you say OP, along OP. Suppose charge is negative, charge is you said to be negative. At that time, the electric field, that is along PO. In what direction force act on this charge? In that direction you have to take. That is the electric field. Is the expression for the electric field. Now from equation number 3, how you define? From equation number 3, how you define here? If that is Q is equal to 1 Coulomb, at that time vector E is equal to vector F. Now you come to the definition of the electric field. The electric field at a point is defined as the amount of electrostatic force experienced by unit charge when placed at that point. Once again I repeat. The electric field at a point is defined as the amount of electrostatic force experienced by the unit positive charge when placed at that point. Yes, if the charge is positive, electric field along OP. It means away from the charge. If the charge is negative, at that time the electric field toward the charge. It is also like this for negative charge. Vector E is equal to 1 upon 4 pi epsilon naught Q divided by R square into N cap. Now this expression is same, only change the direction. This is along OP. This is what you say, that is along PO. You have to take along PO. Only change your direction in the electric field. Now you come to the point now. See here. SI unit of electric field. SI unit of electric field is, that is Newton per Coulomb. Newton per Coulomb. Or what you say, volt per meter. Volt per meter. Unit Newton per Coulomb, or you say to be volt per meter. The dimension formula of the electric field, m raised to 1, L raised to 1, T raised to minus 3, A raised to minus 1 is the dimension formula of the, what you say, that is the electric field. Okay, thank you about that is the electric field. Yes.